This question, the question is saying that heat is slowly added to a 500 chunk of ice at 0 degrees Celsius until it completely melts into water at the same temperature. What is the entropy change of the ice? Okay, so since we've been given that the latent heat of fusion is equal to 300,000, 34,000. So I'll start by defining the term latent heat of fusion. Since we've been given that the latent, which is denoted by LF, is equal to, we have 3, 3, 4, 0, 0, 0. Okay, so that is the latent heat of fusion. So now let us try to define the term latent heat of fusion. So latent heat of fusion is basically the amount of heat energy required to change 1 kg of a substance from a solid to a liquid, okay, without changing its temperature. Okay, so latent heat of fusion is basically the amount of heat energy required to change 1 kg of a substance from a solid to a liquid without changing its temperature. Okay, and the formula which we use to calculate um, the latent heat of fusion, or I can say the formula which we use under the latent heat of fusion, we use it to calculate the heat energy. Okay, I can say the heat added. So we say Q is equal to M multiply by LF. Okay, so this is the formula that we use to calculate the heat added. Okay, so where Q is basically the heat and S is the mass, ML, which is the latent heat of fusion. Okay, so latent heat of fusion is basically constant. It's a constant. Okay, it's a constant. So now the question is asking us, what is the entropy change of the ice? So now let us calculate the entropy change. We've been given the mass, been given temperature, well, been given the LF, which is the latent heat of. So the next thing, we collect our data. So we've been given, so you say data, we have mass, which is 500 grams. We're supposed to convert it to kgs. So kg, you basically divide by 1000. So when you divide 500 by 1000, you're going to get 0.5 kg. Okay, now the next data that we have temperature denoted by T, which is 0 degrees Celsius, and kindly note that our temperature is supposed to be in Kelvin. Okay, so in order for you to convert the temperature into Kelvin, you're supposed to use this formula. Okay, this is the formula that we use. We use K is equal to degrees Celsius plus 273.15. Okay, so since we've been given the temperature to be equal to 0 degree plus 273.15 is equal to, you add, you're going to get 273.15 Kelvin. Okay, so we have converted our temperature to Kelvin. We found 273.15 Kelvin. Okay, so now the next thing, the LF, which is the latent heat of fusion, we've been given to be equal to 33,400, okay, which is in joule per kg, joules per kg. Okay, so the first thing which we're supposed to do, we're supposed to find the heat added. Okay, so to find the heat added, we're going to use this formula, which is Q is equal to M times the latent heat of fusion. Okay, so since we've been given the mass equal to 0.5 kg multiplied by the latent heat of fusion, which is 33,400. Okay, and once you multiply, you're going to get Q is equal to, when you multiply 0.5 times 33,400, you're going to get 167,000 joule. Okay, so now this is the amount of heat added. Okay, so now the next thing which you're supposed to do, we're supposed to calculate the change in entropy. The one which we have found is the total amount of heat added. Okay, so now we're supposed to calculate the change in entropy. So to calculate the change in entropy, which is denoted by S, we use the formula Q over T. Okay, so since we have our Q, entropy, it is denoted by, the change in entropy, it is denoted by S, okay, which is delta S. So our Q we have found to be equal to 167 000 joule over temperature. We use the one which we converted, so which is 273.15 kelvins. Okay, so once you divide our delta S, which is the change in entropy, once you divide, you're going to get 611.40. Once you divide, you're going to get 611.40 joule per Kelvin. Okay, so this is the change in entropy.